In today's lecture, we're going to go over the decorator pattern. The decorator pattern is a structural design pattern that allows you to attach additional responsibilities to an object at runtime. Some of the benefits is it provides a flexible alternative to subclassing for extending functionality. This pattern allows us to follow the open-close principle, one of the most important design principles, which means classes should be open to extension but closed to modification. Each component can be used on its own or wrapped by a decorator. A disadvantage is, as the number of decorators increases, maintaining and debugging the code can become more challenging. Some use cases are when you want to add responsibilities to objects dynamically without affecting the inner object, when you want alternative method to creating multiple combinations of subclasses, or when you want the option to remove a decorator from an object at a later time if needed. So let's go ahead and take a look at this diagram here, because this is what I'm going to use as my template for how we're going to structure our pattern. All right, so what I'm going to do first is I'm going to start with our component here. So our component is going to be our base component, which is going to be an abstract class. So I'll go ahead and label this as our base component. So this will be an abstract class, and we're going to call this beverage. This beverage is going to have two methods. First method we're going to call getDescription, and this will return a string. Second method is going to be cost, which will return a number. All right, so because this is an abstract class and we have these abstract methods, that means that anything that extends this class is going to have to implement these two methods as well. So here we have our concrete component, which is going to extend the component, which is going to extend this beverage base class. So this one is we're going to go ahead and say this is going to be a type coffee. So coffee is going to be a type of a beverage, and this is going to extend our beverage. So as I said, since this beverage is an abstract class, that means that we have to implement these two methods here. So we'll get started with the first one, getDescription. And we'll do something very basic and just say return regular coffee. Next we have our cost. Our cost is just going to return $2 because that's how much I see maybe your typical black coffee would cost. So $2. All right, so now that we have our concrete component, which is extending our component here, we're going to move on to creating a decorator here. And if you notice here on the diagram that this decorator is also extending the component here. But what's different about this class is that it's going to store an instance to our beverage. So it's going to store an object instance of the beverage here. So this one's going to be an abstract class as well, called decorator, and this is going to extend the beverage. So this is going to store our instance. We're going to call it beverage. And where this is going to be protected. And the reason why we're going to prefix this or make it protected is because the subclasses that are going to extend this decorator are going to need access to this beverage instance, object instance. So that is why we're having this protected. Next, we'll go ahead and create our constructor, which is gonna initialize our beverage, or which is gonna initialize and set up our beverage. So we want to say this beverage, and then you have to pass in the argument as well of beverage. And also, since this is extending the beverage, we're gonna have to make use of the super keyword, just like so. All right, so now we have our decorator. So last part of this diagram, or I should say the second to last, is we're gonna have to create our concrete decorators. So for my concrete decorators, I'm gonna have creamer, sugar, and milk. Okay, because these are some common additions that you would probably see for a coffee, right? That a person might add. Coffee, the black coffee, is just a plain coffee, but then when we're talking about the decorators, we're talking about the additions, the condiments. Okay, so now let's go ahead and create our concrete decorators. So the first one, I'll go ahead and create our milk decorator. This is going to extend our decorator. And because this is extending the decorator, that means that the milk decorator is also going to have access to the beverage, right? Because, well, here we have the instance of the beverage, but also see here the decorators is also extending the beverage, our beverage base class here. All right, so for our milk decorator, we're going to go ahead and implement our two methods of get description and cost. So I'll start with get description. Here we're going to say return this dot beverage dot get description. And again, remember, the reason why we're able to make use this beverage is because, again, this is protected. This instance is protected, and this is a subclass of the decorator. So we're able to have instance or have access to the beverage from this class. All right. So here we're going to do return this beverage get description, and then we're going to add to this milk. Okay. So now for the cost. Return this dot beverage dot cost, and then we're going to add the price of how much the addition of milk might cost. So right, this is only for demonstration, but let's just imagine that the milk was an extra 10 cents, right? So you decided you wanted to add milk to your coffee, and just for adding the additional milk, that's an extra 10 cents. All right, so let's go ahead and we can go ahead and repeat the same thing for the additional decorators. So for this next decorator, it's going to be the sugar, and we'll change this to sugar. The sugar, let's just pretend that it's an additional 15 cents. And for our last decorator, it's going to be for our creamer. So we'll say creamer decorator. And swap that for creamer. And then the creamer, let's just say it's 25 cents to add cream to your coffee. All right, so now we have our component, our concrete component, and our decorator, and our concrete decorators. So the final step is to create our client, or to make use of this all this code here. So we're gonna go ahead and start testing. So for our client, we're gonna start off by calling our concrete component, which in our example, it's the coffee, right? Because the coffee is our basic baseline or prototype of what this beverage is going to be. Okay, no decorators, just a plain coffee. So we're going to go ahead and instantiate that and say new coffee and store that in a variable called regular coffee. All right, let's go ahead and test this out. We'll go ahead and console log this regular coffee and call the method of get description on it. I'm going to expand the console so we can have a better look. All right, so if we have a look here, you see regular coffee, because this is just a standalone coffee, plain coffee, no decorators, and we get the regular coffee. All right, so if you recall from here in the earlier description that I said, some of the benefits is that each component can be used on its own or wrapped by a decorator. So in this first example that I just showed you is that this component is being used on its own, no decorator added to it. But now let's get to the second piece of it, in which we want to add or wrap a decorator around this. All right, so let's get back to the code here. All right, I'm going to go ahead and delete that. And so let's say here we have 3 decorators. Let's say we wanted to add milk to our coffee. So the way we would do that is create a new milk decorator instance, and we wrap it, and then we wrap the regular coffee within it. Okay, let's go ahead and store that in a variable, and we'll call that regular coffee with milk. Let's go ahead and console log this. Regular coffee with milk. And then we're going to call the get description on this. If I go ahead and run my code, you see we get regular coffee, and then we have milk as well. Regular coffee and milk. Now what happens if I call the cost method on this? Let's go ahead and execute that. Run the code, and you see we get $2.10. So if we look over here, our regular coffee, just on a standalone coffee, we see here is $2. But then we see here, looking at the milk decorator, it's an additional 10 cents by adding milk to it. So $2.10 with plus 10 cents, it's $2.10. And that's exactly what we get here displayed. All right, so we can go ahead and repeat the same process here. So say now we decide, well, you say, okay, well, I want milk and sugar. So we'll go over here, repeat the same thing, and say new sugar decorator. And we'll wrap the regular coffee with milk within it. Store that in a variable called regular coffee with milk and sugar. And let's see what we get now. So we'll do a console log of regular coffee, milk, and sugar, and call the get description on it. Go clear my console and run the code, and we get regular coffee, milk, and sugar. And if we go ahead and check out what the total cost is, rerun the code, you see $2.25 now, right? Because the coffee is $2, the milk is 10 cents, and then the additional sugar is 15 cents. So that makes the $2.25. So as you can see, as we're adding these decorators on top of our concrete component, which is just the coffee, it's calculating the total of each individual item and then returning to us the final result of that cost. Okay. All right. So see, as you can see here, the decorator can be used in there are many applications in which we could use the decorator pattern. But what I would like to show you now is that this is not the only form or the only approach in which we can call out our decorators. We can actually chain them all together so that they appear essentially on one line. Me personally, I personally don't like it visually. I feel like it's a little confusing, but just know that you have an alternative. Maybe you might prefer this method, okay? It might be cleaner to you, but let me go ahead and show you guys how this looks. So what I'll do now is I'm just gonna go ahead and copy this here, and I'll comment everything out here just so we can kind of start from scratch. All right, so here you see we create our instance of a basic coffee, right? And so by chaining when I say that we could chain it, we could do this. So so the same thing, right? So if I was to say I want to say I want to wrap this, I want to get a coffee, and I decide I want to get creamer on it. So I can say new creamer decorator, wrap that with the milk, or I should say the regular coffee above here. So at this point we have our regular coffee, which is decorated with a creamer. But then we could also wrap around this whole thing with another decorator. So we can say here, new milk decorator, wrap all of that like so. And then I can go further and say, well, I want to wrap something else around everything and say new sugar decorator. So do you see why they call it the chaining? Why this is like the chaining method? Because we're chaining all these decorators all in one line. So we're executing them essentially like in this order here. All right. So, but then let's go ahead and test this out and store this in a variable. Let's just say my coffee, and console log the result to see what we get. So I'll say my coffee and then call the get description on this. Clear the console, run the code. Regular coffee with creamer, milk, and sugar. You see? And we get essentially the same result. So again, you have two ways in which you can approach this depending on what you prefer. Okay, but let me go ahead and let's go ahead and check the cost here real quickly. Let me run this code and you see $2.50. So this calculated the coffee and the addition of adding sugar, milk, and creamer to it. So let's go ahead and let me go ahead and explain to you guys how this code is being executed. Because you're probably wondering how is the calculation of these objects how is it being calculated, right? Like because I know for me, I was trying to figure this out. So if this helps, if we look at this line of code here, you can imagine that for what's happening here when we console log cost is that if the execution of this is going to start here at the sugar decorator. The sugar decorator is going to call the cost on the milk decorator, and then the milk decorator is going to call on the cost of the creamer decorator, and then the creamer decorator is going to call on the cost of the regular coffee. So once it reaches this innermost layer, right? Because this is essentially like an onion, right? We're going from the outermost to the innermost, right? That's what we were doing here. We're going from the outermost to the innermost. So once we get to the innermost of this part here of regular coffee, we're gonna essentially start moving backwards. All right. So the regular coffee then is going to return the cost. It's going to return the cost of the regular coffee and return it to the creamer decorator. And then the creamer decorator is going to go ahead and take the cost of the regular coffee and plus or add the cost of cream being added to it, and sums that up and then returns the total to the milk decorator. Then the milk decorator is going to take the sum of the creamer decorator and add the cost of the milk and sum it up. And then it's going to return that sum to the sugar decorator. And then the sugar decorator is going to take the sum of the milk decorator and add the cost of sugar. And then finally, the sugar decorator returns that final result to the variable here, which is the final result that we get. So if you think of if you were probably thinking about recursion, and if you thought recursion, you're absolutely right, because this is essentially recursion. That's what's happening. Or you can think of a stack, right? If you're familiar with stacks, you know that functions are added onto a stack. So it follows the Philo approach, right? First in, last out. So what happens is, as I was showing you, is that essentially you have the sugar. If we follow this this line again, as I was showing you earlier, is you can imagine a stack that it starts off with the sugar decorator, and it has this cost method to it. Oops, no, not like that. All right, so it has this cost. So it adds that to a stack, and then it goes to the next one in line here and adds that to the stack, which is the milk decorator. All right, and adds the cost method of that decorator. And then it goes ahead and adds the creamer decorator. And then finally it adds the regular coffee to the stack, just like so. All right, so this is our stack. So as I said, Philo is first in, last out. So at this point we have this stack, and then now at this point, once it reaches the innermost of the method, it's going to have to go backwards. So this stack right here is going to start popping off methods from the top. So it's going to go ahead and say, what is the cost return? What's the cost of the regular coffee? So in our case, so in the case of our example, the coffee was just $2, right? So it's going to pop off this regular coffee from the stack and return the $2 to the next one in the stack, which is a creamer decorator. So creamer decorator is then going to add the cost of adding, or is going to add the cost of the regular coffee and add it to how much a creamer would cost, and then return that total to the milk decorator. And then milk decorator will add the total with the addition of the milk cost and return that to the sugar decorator, and then the sugar decorator will make the final calculation and return the final result and return the final result. So that's exactly what's happening. So the stack is, so recursion is happening, and also essentially a stack call is being implemented as well. Okay, so there you have your decorator pattern. Hope you had you found value in this video. Thanks for watching.